Ask an AI a question, and it types the answer one word at a time. Meta just released Muse Glimmer, an open model that gets around that by guessing ahead. Muse Glimmer is Meta's first open weights language model since April of last year. Its 30 billion parameters, the numbers it learned in training, would need over 55 gigabytes of memory at full size. That is more than any graphics card a person can buy. So Meta squeezed each number to about 4 bits, which puts the model under 20 gigabytes. On a 24 gigabyte card that leaves room for its working memory, the part that reads images, and a second model that guesses. Meta ran Muse Glimmer against 2 rival open models its own size, Google's Gemma 4 and Alibaba's Qwen 3.6. Across 22 tests, Muse Glimmer wins 12 and loses 10. The wins cluster in one place. Using outside tools, searching, and long documents, the losses cluster in another, and both go to Qwen, driving a desktop and working at a command line. That is Meta's own table, and Meta gave each rival its best published score. Artificial Analysis, the outside firm that measured 8 of those rows, puts Muse Glimmer at 35 overall, just behind Qwen at 38. That second model ships in its own repository. It carries 2.5 billion parameters across 5 layers, about a 12th the size of the big one. It has one job: guess what the big model is about to say, and it guesses a block at a time. It lays down 16 empty slots, and fills every one of them in a single pass. 16 is what ships in the file and what Meta measured. To produce a single word, the graphics card pulls the whole model through its memory. Its arithmetic sits waiting for most of that trip. Checking 16 words costs the card barely more than checking 1. So the guesser hands over 16 words at once. The big model then grades the whole block at once. It keeps the run of words it agrees with, corrects the first word it disagrees with, and carries on. Every word that survives is a word the big model approved. So you read the answer the big model would have given on its own. A bad guess costs a little time and leaves that answer alone. A guesser working from the words alone has to predict the future from scratch, and it guesses badly. The researchers who designed this one trained exactly that version, a 5-layer guesser with no window into the big model, and they call its speedups modest. So Muse Glimmer wires this guesser into the big model's insides. While the big model reads your question, Muse Glimmer taps a summary of what that model is thinking from 5 of its 52 layers. That summary goes into the working memory of every layer of the guesser. Guessing a block of 16 costs, about what guessing one word costs. So the guesser can afford to be deeper, and depth is what makes its guesses good enough to keep. A token is a chunk of text about the size of a word. On an RTX 5090, a $2,000 NVIDIA graphics card, Muse Glimmer goes from about 75 tokens a second to 233. Same answer, 3.1 times quicker. On Apple laptops, Meta measured smaller gains on different software. 1.8 times on an M5 Max, 1.5 on an M4 Max. All of it is Meta's own measurement, one request at a time. AMD has published its own hands-on numbers, up to 53 tokens a second on a Radeon card. The before and after pair the 3.1 is made of, only Meta has published. So the dribble of one word at a time is a memory problem, and the fix is a guess that gets checked. Both squeezed builds and the guesser sit on Hugging Face, under Apache 2.0, ungated. Meta says tune support for running models at homelands in the coming days, so these numbers are the floor.